Alright, welcome back everybody. We are going to be dealing with 6th grade math today, and we are going to be focusing on the number system. Alright, so let's take a quick peek at what kind of things we're looking at. Okay, I'm adding decimals. That doesn't look that bad. I got some graphs, find the distance between 2 points. That's just counting. I got some multiplication for number 4. I got quadrants, so again, graphing. Looks like I got horizontal number line stuff. I got distance stuff, absolute values. Okay, that's not bad. I got to deal with the fraction. I'm dividing numbers. Ooh, okay. Subtracting numbers with decimals, not horrible. Multiples. Okay, not that bad. I think we could do this. The other thing I noticed is, oh, I got it. There it is. Okay, I was like, there's not a lot of reading. There it is. And it looks like only 2 out of the 15 problems gave us a calculator. That means we got to do all this on our own. So let's see how much of this stuff we remember back from like elementary school. Like, ay. All right, so let's go ahead and get into this. We're going to add decimals right here. And the thing about adding and subtracting decimals is that we got to line them up. So one of the things, again, when I was your age, actually even younger, right, when I had to learn this, my teacher told us to go ahead and put a bunch of zeros so that everything was kind of lined up, and it has to do with organization. So now I can go ahead and add vertically. So 5 plus 0 is 5, 4 and 0 is 4, 3, 7 is 10, carry the 1. Let's put our decimal place there because it belongs. Remember, your decimals gotta line up. And then I got 2 plus 6 is 8, plus 1 is 9, and a 1 at the end is 19. So 19.045. Not that horrible. Okay, so the key thing here, and like this is where we mess up, you guys got to line up the decimals when adding or subtracting. Look at the graph below. Oh my god, guys. When I make this kind of like dramatic thing, like it's like you guys got to get this one right. Like, please get this one right. Okay. You guys seen quite a few of these in a bunch of your tests already. So find the distance between points B and C. There's B. There's C. What is the distance between these 2 points? And the main thing I see you guys mess up in, and I saw it a lot in your performance test, I had a bunch of like grid, right? Remember it was like something with camping or whatever, or it was that 7th grade. I don't know. I think it was even high school too. I had kids make the same mistake where they had a graph with like a grid like this. So what am I talking about? You find the distance, you need to count the squares. So there's 1, 2, 3, 4, 5, 6. The distance is just 6. That's it. And if you want to be clever, think about it, because I'm on the opposite sides of my x-axis. I'm going from 2 and negative 4. Remember, this is a 0. So if there's 2 up here and 4 down here, we combine them and we get 6. Where I get kids messing up, and again, little mini lessons, but it's just, I don't want you to do this. They'll be like, oh, that's 1, 2, 3, 4, 5, 6, 7. So a lot of students will pick 7 because they're counting lines. You gotta count the squares for the distance, not the lines. Ugh, okay, simple mistake. And like I said, I don't want you to do that because it's an easy question. You just gotta count. Number 3, look at the points on the plotted. Oh, sorry, I'm gonna read this. I'm getting ahead of myself. Look at the points plotted in the number line below. Okay, I see a bunch of whole numbers. And they cut those whole numbers into like parts. Ew, that's fractions right there. Read each statement and determine whether each statement is true or false. Okay, no problem. The value of point A, so let's do one thing at a time here. Get my color set. Is greater than negative 2. So where is A? A is right there. Is that greater than negative 2? No. Remember, and here's the biggest hint, right? On a number line, the number on the right is larger in value. So that is not negative. It's not going to be bigger than negative 2. It's going to actually be smaller, all right, in terms of value. So that's false. Let's look at the next one. Where are we at now? The value of point C is larger than the value of point B. So when I have B and C connected, C is larger. Is C on the right? Yes. So that is true. Next one. The value of point D is larger than A. So there's D, there's A, and yeah, in this case, it is larger. Okay, and this one you should know because it's positive and A is negative. Positive numbers are always going to be larger than negative numbers. And now here's a fraction. I knew they threw it in there. So let's see. The distance between C and D is 2.5. So C and D. So how far is it from here to here? Well, from here to here is 1. Because notice there's 1, 2, 3, 4 pieces that makes a whole, right? So that means I got 1, 2, 3, 4 pieces that makes a whole. 1, 2, 3, 4 pieces that makes a whole. So there's no. I don't want to do it. I just want to show it visually. All right, here we go. So I got this. So that's 2 pieces, right? There's 1, there's 2, and it says 2.5. Well, there's 1 piece right there, so that's not a half. A half would have been 2 out of 4. That's 1 out of 4. So that one is false. Okay, number 4. If you know that 246 times 81 is 199.26 or 19,926, enter the exact value product of, looks like the same numbers being multiplied. What do they want you to know here? Well, if you notice, right, when I did the quick little preview, they wanted you to add numbers, subtract numbers, divide numbers, and a lot of them had decimals. So they want to know if you understand the decimals, right? Like, what do you do with them? Do you align them? Do you subtract them? Do you combine them? Do you move them? What do you do? So one of the things, hopefully, remember is if you are multiplying numbers, 24.6 times 8.1, you don't have to line them up. These just happen to. What matters when you multiply them is you have to count the decimal places. So because this one is 2 decimal places, right, total, on the right side, when I get my total all the way at the bottom, I'm going to have to move it over twice. 1 decimal, 2 decimal places. So my answer is simply just 199.26. All right, next one. Let's see. Second quadrant. Let's look at this. This is super important right here. In all grade levels, even high school, I get so sad because so many students still don't know how to graph points. Okay, and you guys have been learning this in 6th grade, and it never ends. Every single year, summer, it doesn't matter. You will graph points to like the end of time in math. Okay, frustrating. All right. So the second quadrant, those are my quadrant numbers. You always start on the top right where everything is positive. And when I say that, let me clean this up actually. I mean, this is my positive X and this is my positive Y. And then you go counterclockwise for the quadrants. I don't know why it's not clockwise. Don't ask me. Okay. So in this case, I want the second quadrant. Not a big deal. I just want to know what all the points are going to be right here. So in order to do that, I just got to check what they should be. What should be positive and negative? Well, I went to the left on my x-axis, so that means my x's are negatives. And then I went up in my y, so my y should be positive. So in other words, my first number is negative, my second number is positive. And notice this is a choose all, so I'm going to pick 2 or 3 options. If I wanted 1, then I would have just had a multiple choice question. If I wanted all, then that's just super rare to be all, okay? And I said this before, like, when I was your age, right, our test had the all of the above option. That sucked. Like, we hated that thing. So this one is basically just pick somewhere in the middle, right? So if they give you 4 options, don't pick 4, don't pick 1, pick 2 or 3. Usually, okay? Usually. Like, when I say usually, I mean most of the time. All right, 2 or 3. So let's see. My x has to be positive. No, my x has to be negative. That is not negative. That is not negative. That one's okay. That one's okay. And my y has to be positive. That one's positive, that one's positive. So that one and that one are my options. Okay, next. Let's see, read the settings below and determine whether each statement is true or false. So let's see the distance, and distance is always positive. The distance of 2.18 is 0 on a number line is the absolute value of 2.18. Well, guess what 2.18 is? Absolute value is just 2.18. So yes, that is true. That's how far it is. It's positive. So negative 4.2 and negative 4.2 in the absolute value form are on the same point. No, because this one will turn into a positive 4.2. So they are not on the same spot. The distance from negative 8.8 and 0 is the same distance from 8.8 and 0. Yes, that is totally true. Okay, so it's the distance. It's the same length all the way to 0 because they're both opposites. Okay. All right, which equation? The equation below is missing a number. Enter the fraction. They literally told you it should be a fraction that would make the equation true. So what do we know about fractions? If you've taken that quiz already, it was a bunch of fractions. We had to add, subtract, multiply, and divide them. You should have learned that the first fraction, you keep it the same. When you divide it, you change it to multiplication. And the second fraction, you got to flip it. So we get this equation, really. So the idea is, when you're multiplying fractions, you multiply straight across. So in other words, what times 5 equals 15? So if you go with your multiplication tables, 3 times 5 equals 15. And then what times 4 equals 28? And this one's going to be 7 times 4. So I got 3 7s. And you should probably have a fraction button on your calculator that looks like this. Or you might have it like this. Or you could have just said 3/7. Okay. All of those work. I just kind of giving you a heads up. Okay. Because usually your keyboard will have a fraction button when you're doing math. And if you don't believe me, right, here it is. And because you're usually using the Desmos calculator, and you will notice that the Desmos calculator has a fraction button right there. It's really nice. Okay. Okay. Moving on. Divide those two numbers. Oh, yeah. Okay, it's going to be a long one. Let's see. Alright. I don't know why I did it that long. Sorry. So 1,000 into 6, 8, 4, 6, 5, 8. So 1,000 does not go into 6, does not go into 68, does not go into 684, but it goes into 6,000, blah, 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 6 times. Because that gives you 6,000. Subtract those, and I get 846, bring down the 5. So 1,000 goes into 8,000 and change 8 times, because that gives me 8,000. You can see a pattern here, hopefully. 4, 6, 5, bring down the 8. So now 1,000 goes into 4,000 and change 4 times. So give me 4,000. And I get 658. So can you see how my number is getting smaller and smaller, right, as I get to the end? So in this case, it looks like I'm just going to add 3 zeros to be safe, because I don't know how many more times I'm going to have to bring those down. So bring down my first 0, because I ran out of numbers. Let's put my decimals there. Now I got 6,580, so that's 6 times, which gives me multiplying times 6 to be 6,000. Subtract to get 580, bring down another 0. 1,000 goes into 1,500 5 times, so that gives me 5,000. So when I subtract them, I get 800 and bring down. It looks like my last 0, because 1,000 goes into 8,008 perfectly times. That sounds weird. 8 times perfectly, I guess. 0 is my leftover, so I am done. There's no more remainder. So in this case, my number is 684.658. Whew, there we go. Alright, and if you didn't know the shortcut, by the way, here's your little mini lesson. I mean, I know you guys probably complain about why they're long, but it's these little mini lessons, okay? I think they're helpful because it'll save time. So you guys hopefully know, like, if I do 3 times 10, that's just 30. If I do 3 times 100, that's 300. If I do 6 times 1,000, that's 6,000. If I do 12 times 100, that's 1200. If I do 10 times 40, that's 4, and then there's 2 zeros, so then I put them. So that's the shortcut you hopefully have learned at some point. So essentially, when you're multiplying by a 10, you just, however many zeros you multiply, you just add them, right? So I just added those. I added those. It wasn't a big deal. So the reason you added them is because technically my decimal place is right here, and I moved it over once. My decimal place was at 3, and I moved it over twice. My decimal place over was at 6, and 1, 2, 3. So when you multiply, you move the decimal to the right. Guess what happens when you divide? You move the decimal to the left. So my decimal is always at the end of my number, and if I divide by 1,000, how many is that? That's 3 zeros. So that's 1, 2, 3. And guess where I put my decimal place? Right there. Now in the short, if you can get this, great. If not, it's okay. All right, you can always do it this way. I'm always gonna get it right, assuming I do the right steps. Every time you count a zero, it's like you're multiplying by 110 times 10, and this one's actually 10 times 10, right? Because that gives you 100. This is 10 times 10 times 10. So every time you multiply times 10, you move the decimal place over once. Anytime you divide by 10, and this one is 10 times 10 times 10, you move it over once to the left because you are dividing. Okay, anyways, that's your little mini lesson. Anyways, moving on. Okay. On a horizontal number line, negative 18 is located on the left of negative 6. Enter the inequality. Remember, inequality is that one, that one. So I shouldn't say that. Let's use our vocabulary here. Less than, greater than, less than or equal to, or greater than or equal to. So I got negative 18 and I got negative 6. What inequality goes there where they can't be equal? They're not the same number. So which one is it? And remember, was it this one? Did I just do this one, or was it the one? Nope, it's right here. Boom. Look, super important. The number on the right side is always larger. So as I remember this from my, was it my, oh my god, when was it? I think it was Miss Grijalva in elementary school. Damn, Miss Grijalva, that was so long ago. She taught us inequalities. Yeah, I forget what grade level, but I just know it was elementary school. And she said that the alligator always ate the bigger number. And if we're looking at a number line, it said the negative 18 is on the left side of the negative 6. So the alligator, can you see the alligator here, is eating the bigger number. In this case, it's the negative 6. Okay, so vocabulary time. Negative 18 is less than negative 6. Or some of you guys could have flipped it and said negative 6 is greater than negative 18. Either one of those is correct. Okay. Moving on. All right, if yours isn't an alligator by a shark, that's fine too. She would switch it up. Any other animal is unacceptable. I'm just kidding. I don't care. Okay, but the shark and an alligator always seems scary, so whatever. All right. You and your friends order an extra large pizza and tell the pizza shop not to slice it because you will do it at home. For some reason, I guess, sure. You cut the pizza in half and decide to split one half of the pizza among 5 people. Enter the fraction of the pizza that each person got. Okay, so I got a pizza. There it is. Wonderful. What did I do with this pizza? Not to slice it, okay? I cut the pizza in half. So there it is. Boom. That's awesome. And decide to split half of the pizza among 5 people. So I'm going to split this half. So there's 1 piece, 2 piece, 3 piece, 4 piece, and 5 piece. I mean, they're pretty equalish. All right, let's just they're even. Let's just say they are. So that one got split amongst your 5 friends. So the question is, what is the fraction that each one of those people got? So it is very simple to say, hey, that is 1 out of 5 slices. But wait a minute. No, no, no. The fraction of the pizza. That's half the pizza. If you want the pizza, you could have kept going all the way here and kept slicing it all the way. So the whole pizza is actually 10 slices. So in reality, you didn't get 1 out of 5. You got 1 out of 10. So hopefully that makes sense, okay? Because it wanted the whole pizza, not the half that you cut. All right, enter the least common multiple of 6 and 15. Oh, these are not that bad, guys. You guys got to get these right. So these ones, I always tell my students, it's okay to use your fingers. I use them every now and then when we have to count. Okay, it's not a big deal. If some of these are like, how good are your multiplication tables? Sometimes you're not, but you're good at counting. What I mean by that is I'm going to start, and multiples are just your multiplication table starting with 6. What's the next number after 6? Well, I have to add another 6. So I'm literally using my fingers. 7, 8, 9, 10, 11, 12. Let's start again. 13, 14, 15, 16, 17, 18. Excuse me. And so on. Now, luckily, I do know my multiplication. Luckily, I do know them. So it should be 6, 12, 18, 24, 30, 36, 42, 48. And I'm going to stop there. Okay. Enter least common multiple of 6 and 15. 15 is a little bit more annoying, so hopefully they don't give you something like this. So again, I made these quizzes up, so sometimes I have regrets on picking certain numbers like I am right now. But 15 is not horrible. 15 plus 15 is 30. Add another 15, that's 45. Then I get 60. Then I get 75. Then I get 90, and I'm going to stop. So what do they want? They want the least common multiple. So which one is the lowest one? I'm going to start with the bigger number first. Is there a 15? No. Both. Is there a 30? Yes. So that is it. It was just 30 for both of them. So just say you just got to count. Okay? Figure out which one they have in common. This one's supposed to be a free one, guys. All right? Okay. Let's subtract. Oh, this is the one people struggle with. Okay? So let's pay attention here. So I got 98.76. Minus, and again, I gotta line up my decimals, right? I gotta line them up. No, I don't want to use that. I want to use the highlighter here. So I'm gonna take my 98.76, and I'm gonna have 5.432. Everywhere there's a gap, I'm gonna put a 0 like that, and then I'm just gonna go ahead and subtract. So let's see. I'm going to go ahead. I can't subtract 2 from nothing, so I'm going to borrow from the 6. I'm going to borrow 1, so I'm left with 5, and the 1 goes there. So that gives me 8. 10 minus 2. 5 minus 3 is 2. 7 minus 4 is 3. My decimal lines up right there. 8 minus 5 is 3, and 9 minus 0 is 9. So this one wasn't too horrible. Difference was 93.328. Alright, last page, please. Yes, last page, guys. So last couple problems here. Last 3 problems. They look super wordy, but I promise you, usually when they're wordy, they're pretty straightforward. Okay? As far as like the answer, they just want you to read a lot for some reason. I don't know why. Okay? So let's see what I'm talking about. The data below shows temperatures recorded in January 22nd, 2025 at 2:35 p.m. Pacific time across different cities in the world. Yeah, I literally Googled it at that time. Okay, those were the exact temperatures. So determine whether each statement is true or false about the temperatures in those cities. Okay, so I just got to compare these. Let me read to see what I got to do to make things easier on myself. Toronto has a higher temperature than Beijing because, okay, so I'm literally comparing numbers. So one's the coldest, the furthest from 0. You know what? It's going to be easier to arrange this from coldest to hottest or whatever. So because it's temperatures, I'm going to go vertical. Alright, there's a 0 there. So let's see. I got -6 right there. I got -10 down here. I got a 24 right there, and it's not to scale. Okay, so we're not evenly just like distance. Okay, and I got 31 right there. So my 31 was Buenos Aires. My 24 was Cape Town. 0 was nothing, just so I could see where there's a positive and negative. -6 was Beijing. And -10 was Toronto. Okay, so now let's look at this data, because all I do is organize it. Let's see which one's true or false based on the statements. So Toronto is higher than Beijing because -10 is bigger than 6. No, I mean, this one, as you get taller, it gets hotter or higher. So in this case, if I'm looking at Beijing and Toronto, it says Toronto is higher. No, Toronto is lower. That's false. Next one, Buenos Aires is the coldest. So Buenos Aires is all the way at the top. No, Buenos Aires is the hottest here. So that is false. Okay. And then finally, what's left over, Buenos Aires temperature is further from 0. So how is it from 0? 31. And all the other ones are way closer. So that's the furthest, so that one is true. So that was it. I mean, it was a little bit of reading. It wasn't that horrible, right? We just had to like organize some data and just answer the questions. So we just got to be patient with the reading. Here's another one that I hate to do in math, but in the end it's so easy. All right, because they are telling you to basically to play teacher. And anytime I play teacher, okay, I just do the work myself. And when I do it myself, I assume I'm going to be correct. And then what I love is when they tell me like what the answers were. And look, the answer is. So I just got to match, most likely, I got to read it, what my answer is and who got it right. Okay? So let's see if that's the case here. Alyssa, Marcus, and Raul were trying to add fractions. Their work is described below. I don't care what they did. Okay? I'm going to add them myself because I want to see who was right, first of all. And if I'm looking at my answers, everyone could be wrong. Or one of those kids are right. Okay, so let's see. What do I do with adding fractions? I'm going to take my 2/5. I'm going to add the 4/7. And when we add fractions, I know that the denominator has to be the same. So in order for the denominator to be the same, you have to find the lowest common denominator. A lot of vocab here, right? Well, my shortcut to adding fractions as a student is just to multiply the two denominators. So if I have a 5 and a 7, I'm going to multiply the 5 times 7. And I'm going to multiply the 7 times 5. But here's the kicker. You can't just multiply this first piece by 7 on the bottom. You have to be fair. So if I multiply the 5 times 7, I have to multiply the numerator by 7. Okay? So what does that give me? That gives me 14 over 35. And then for the bottom one, if I multiply the 7 times 5, I multiply the 4 times 5. So that gives me 20 over 35. And now that my denominators are the same, and I'm happy with that one and that one, I add the numerators. So 14 plus 20 is going to be 24. No, 34. Ugh. Got that one. Over 35. So what happened here? Alyssa said it's 6 over 12. Alyssa's wrong. Marcus said it's 6 over 25. Marcus is wrong. And then Raul says the answer is 34 over 35. Okay, Raul is correct, but let's see why Raul is correct. So you need to multiply 2 times 7 over 7. Did I do that? Yes, I did. Did I multiply that? Yes, I did. This will give you the same number. Keep the values of the original fractions the same. Oh, so in this case, Raul is right. Now here's the thing that's interesting. They technically gave me a calculator. So how would I use that to my advantage? So let's look at this. I have a fraction button. I had 2. Put a fifth. Get out of there. And I'm going to add another fraction which has 4 and 7. Now this is again, you gotta know about the calculators, or you're like, it's a decimal, that doesn't help me. Well, that's true, but I can technically change all of those into decimals. Put 6 divided by 12, find the decimal. 6 divided by 25, find the decimal. And 34 divided by 35, find the decimal. And then you can match it. That's one way to do it. The other thing is, do you see the little circle next to your answer? It has a fraction. Oh, look at that. It just changed it to a fraction. So the thing is, and I got to kind of explain this to you, right, as a teacher now, what the test people have in mind probably, is you can use the calculator to find the answer. That's perfect. Great. So did I have to do all that work? Probably not. The only thing I can think of is, what if more than one person had the correct answer? So yeah, right, you can kind of bring it down to 50-50, but you have to know how to explain it. So did you know that what Raul did, right? Or did you just use a calculator and get lucky? Because what if somebody else got 34 over 35 but explained it differently and they did totally wrong and they got lucky? Who do you pick? You know what I mean? That's the only thing I can think of why they would give you a calculator. Maybe two people got it right, and you got to check the correct one. All right, so just be careful. All right. And are we done? Yes, last question. All right, last question, guys. I'm going to leave the calculator open because there's a button right there. So what do we got to do? You are on a road trip and your Costco size trail mix bag is half full now. So can I picture this? Okay, there's my trail mix. And half of it's full. So this one is gone. Okay? So you already ate that. If a serving of trail mix is 1/16 of a bag, enter the number of servings in the trail mix left over. So let me think about it. Okay. This number is important. So it's 1/16 of the bag. So how many servings are on there if 1/16 is one serving? Well, that means there's a total of 16 servings in the whole bag. Well, if the whole thing is 16 and I just said that half are gone, well, that means that I have 8 and 8 if I split it in half, so then I have 8 servings left over. Not that bad. Okay. So, right. So that takes care of this. All right. Let's see anything I just want to throw in there for you guys. So again, notice these true and false. They weren't all true. They weren't all false. All right. Playing teacher. Always do your own work and then compare. It looks like they wanted you to know about decimals. Okay. What do you line them up with adding, subtracting, dividing? Make sure you keep the first one. Change the multiplication and flip it. Know your multiples. Okay. Graphing, know how to graph, know where the numbers go, and that should be good. Okay, these I always say are easier for a lot of us compared to all the other ones that are work. Okay, for most of us, if we just know how to graph, we can get a bunch of questions correct on the exam. I always say that to every grade level. If you just know how to graph, I guarantee you will get some of those questions correct, because usually they just want something simple like that. Can you still graph points and count, basically? All right. So that is it for this one, guys. Until next time.